our last scheme is called Simpson's rule. So the idea behind Simpson's rule is, again, the same sort of thing. And with the trapezoidal rule, we looked at a trapezoid. With Simpson's rule, it's a little bit different, that we're going to be looking at a parabola, because the thought behind this is, as you can see on our example, when you're approximating with line, you're going to be missing some. So we're approximating a curve with a line. We might do better if we approximated our curve with a curve. Okay. So, and we do know how to find the area under a parabola. In fact, I'm not going to do this, but it is linked in the Canvas extra materials. If I take some parabola, right, wherever it is, and just we'll call this y0, y1, and y2. This is some kind of parabola here. And then this would be delta x. The area under this parabola you can compute, and it is in your book. It's delta x over 3 times y0 plus 4y1 plus y2. Now you'll notice it doesn't quite look symmetric. Maybe the top isn't exactly at y1. It doesn't have to be, okay? But you have a parabola through any 3 points. You know that given any 3 points, we can find a parabola through them. And this is actually the area underneath. So the idea with Simpson's rule is to use this. You do need an even number of intervals for Simpson's rule, because what you'll see is that it uses 2 intervals to make the parabola. Right, come on. Is it working? There we go. There we go. Okay, so what do I mean by make a parabola? This one actually is kind of nice. It'll show you. So it broke them up. These are our first 2 intervals, right? And so with those intervals, that is a parabola through those 3 points. Now for my next one, I have these 3 points. And so that's the next parabola. They're going to meet up at the ends, right? Because I use the same point, but then I have all these parabolas. We can show them all, but I find that's kind of difficult to see, so I prefer to show them one at a time, if you're going to look at that. So what we're going to do, very much the same as we did with the trapezoidal rule, is we're going to add up all these parabolas. Now, each of these parabolas then has the area underneath each of these parabolas, then it has this formula, the y0 plus 4y1 plus y2. But the same thing is going to happen as with the trapezoidal rule. This one on the end, it's y2 for this first parabola, but then it's y0 for this next parabola. So those inner points, which here are given to you with a darker line, with a solid line, are actually going to be, added in twice. So they're going to have a coefficient of 2. Now the middle point is only added in once, but it comes with a coefficient of 4 because of the way this area comes when you actually integrate this. So let me give you, let me just stop this for a minute, and let's write down the final formula, the whole formula for S, and then we will do our example with that formula for S. So Simpson's rule, so it's going to be Sn. We're going to have delta x over 3. And we're going to start from f of x0 plus 2f of, no. It's 4, right? It's going to be 4. I got to get, not 2, I got to get 4. 4f of x1 plus 2 f of x2. And now in the middle, it's always going to be 2, 4, 2, 4 plus dot, 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 plus until you get to the last one, 4 f of xn minus 1 plus f of xn. Okay, so in the inside, it's going to go 4, 2, 4, 2, and end in with the 4. And that will always happen if you have an even number of intervals, right? So it has to be an even number of intervals for this to work out. So let's do it in this case. In fact, I'm just going to write it out entirely here. So delta x was pi over 8, so I end up with pi over 24 here. And again, sine of 0 is 0 for the first one. I've got sine of 0 plus 4 sine of pi over 8 squared plus 2 sine of pi over 4 squared. And I just keep going, right, with the 4, 2, 4, 2. Okay, 4, 2, 4, 2. And then I end up with, wait, let's just do it over here. 4 sine of 5 pi over 8 squared, 2 sine of 3 pi over 4 squared, 4 sine, yes, see how that works properly. And then my last one is by himself, he doesn't have a 2 or a 4. Okay, and when I work all of this out, it's going to be 0.8367. That's what I got. Okay, so this is actually still a bit of an overshoot, but as usual, if I take more points, I will get something closer.